Okay, so let's talk about functions. So last week we introduced the concept of functions, um, and we talked about how functions are really useful because they allow us to not have to reinvent the wheel every time we want to do something. And you've already had practice at using some of the countless built-in functions stored in external libraries, external modules, etc. Things like as we've just seen, the random function within the random library allows us to generate a random number between 0 and 1, really useful function. The print statement is in itself a function as well. So you're used to using functions now, but the beauty of a programming language is we can also write our own functions. And most programs that you will write can and should have their own functions, unless you're doing something very trivial. Because we usually want to do the same thing a number of times, but we don't want to have to keep writing the code to do that. So in order to define a function, we simply use the def command. And what we do is we tell Python the name we want to give that function, the inputs that are needed for the function, if any. Remember, there are some functions that don't require any inputs, and the block of code that represents what we want the function to do. Usually, we'll also return some sort of output, although again, not always. You don't have to return an output. So remember back to this diagram that we talked about back on the very first day, where we talked about principles of programming. We said that a function consists of a function name, a body, which is the stuff we want the function to do, and then a number of inputs coming in. We do something with those inputs, and then we generate some outputs. And that's basically all we're doing. So let's look at an example of a simple function that we might write in Python. So let's just say we want to write a function that takes two numbers, it multiplies them together, and then it works out whether the result's higher than 100, and returns a Boolean to indicate whether it is or not. So not a particularly complex or probably useful function, but demonstrates the point. So here we can see that the first thing I do to define the function is use the def command. And then I can specify the name of the function. So I've called my function multiply and check. Then we open our brackets and then we specify the inputs. So these are the things that we're going to feed into the function. So in this case, I just want a function that takes a couple of integers. You can call these things anything you like, but obviously try and call them something meaningful. So I've called mine number 1 and number 2, and then we use our colon to say, and now I'm going to tell you what this function will do. So then everything else that's in the function body, in the indented space here, represents what the function is going to do when we call that function. So the first thing I'm going to get the function to do is to multiply them together. So I'm going to multiply the two numbers that are passed into that function, number 1 and number 2, and I'm going to store that in a little variable called result. Now, result here is an example of a variable function. It only exists in that variable. It's disposable, essentially. It's used for the variable when it's called, and then it's not used again. So it's only used within that function. So we store in result the number 1 multiplied by number 2. And then we use an if statement here to say if the result's greater than 100, return true, else return false. Now the return statement here is how we get the output back. So when we call a function, we call it by its name. We say, do this function. Here are the inputs you need. And then the function will do its thing. And then it'll need to pass back the outputs. So if we go back to this, remember we've got inputs. So we call the function by its name. We pass it a number of inputs. The function will do something with those things, and then out to the other side will spew these outputs. And it's important we use the return command to return this. So in this case, what we're returning here is a Boolean value. It's either true or false. It's either greater than 100 or it's not. So that defines the function, but nothing will be done. So if we write that in our program, Python will nod sagely and say, great, thank you. I now know what to do when you tell me to multiply and check. But it won't do anything. It won't do the function body yet. It's just, you're just telling it by defining, you're just saying, when I tell you to multiply and check, this is what I want you to do. I want you to take two numbers, I want you to multiply them together, and then I want you to give me back a Boolean value that's either true or false, depending on whether the result is greater than 100. But it won't do that until you call it. So we also need to call the function. So let's imagine we've written our function here. Now, pretty obviously, you need to define the function before you can call it. So you need to make sure in your program that your function definitions, which usually take place towards the start of the program, happen before you use them. Python needs to know what the function is before you call it. If you don't, it'll say, I don't know what that function is, because you've tried calling that function before you've told it what it is. So here's an example. Here I've got the multiply and check definition here. Then I'm going to use that function that I've just written. So here I just grab two user inputs from the user. So you're well used to doing this now. So just ask them to input a number, cast that as an integer, ask them to input another number, cast that as an integer. Then I'm going to take those two numbers and I'm going to use them as the inputs to the multiply and check function. So here I have a variable that I've called isResult over 100. Now that is going to be a Boolean. And the reason it's going to be a Boolean is because it's going to store the result of that function. It's going to store the output. And the output, we know from that function, is a Boolean. So here, I call the function by its name, multiply and check, and then I pass it two values. Now it's expecting two numbers, because it's going to multiply them together. So I pass it two numbers. And the two numbers I pass it here are the two numbers that I've read in from the user and cast them as integers. Now you'll note the names that I've given to the variables here do not match the names I've given up here. Now they can do, but they don't have to, because in your function definition, you're just saying, here are two names of inputs, and throughout my function, I'm going to refer to those inputs by those names. But that doesn't mean that the variable names that you pass in have to be the same. All it's expecting is two numbers. And then when it goes into the function, it'll then refer to them as number one and number two. But in my case, I'm going to pass in user input one and user input two, which is what I've read in from the user here. So what will happen? Python will call this function with these two numbers. So it'll ask for the user for the two numbers. It'll then pass into this function. Those two numbers will then be multiplied together and stored in result. And then depending on whether the result is greater than 100 or not, the function will then spit out the other end a true value or a false value. That value will be stored here in isResult over 100. So the bit before the equals, the bit before the assignment operator here, that's going to store the output to the function. So in this case, that's going to store either true or false. So this will run the function with those inputs, the function will run, and then true or false will come back and be stored in this. It is result over 100. And we can see that because then if we use a conditional logic statement here and said if isResult is over 100 is strictly true, then we can print I knew you'd think of big numbers or something like that. Okay, so these are the key things to remember with a function. You need to give it a name, use the def command to define it, you give it a name, you give it the inputs you want, and the names you give the inputs in the definition are the names you will refer to in the function body. The function body then defines what you will do with those inputs, and then you return some outputs. And the returned outputs, when you call that function, the returned output will be over here. So it will be whatever you put it to the left of your assignment operator. And that's basically like saying, so that statement is the same. If we'd have written isResult over 100 equals true, well, you'd be used to seeing something like that. You're just setting up a variable and you're assigning the value true. But instead of hard coding the value true, what we're doing is saying, well, run this function and let that decide what that value should be. Okay. Everything making sense so far? Does anybody have any questions about that?
Dan,
Hello?
it's Richard here. You you could discard the is result over 100 variable and just put the function into the if statement, couldn't you?
Yes, you could. Yeah.
Just
Oh, yes, sorry, in
yeah.
here,
So
yes,
you
you
say
could.
if multiply and check open bracket user input you want to equals
Yes,
true,
yes.
then yeah. So you don't have to use that variable.
No, absolutely not. No, no, no. So I'm just breaking that down to show you that it's stored in a variable. So you're right. You could put if multiply and check user input one, user input two equals true, and then it'll run the function here, and then that output will then be that value, which will then be compared to whether it's true or not. So yes, you can do that. Okay, so you're going to have a practice at doing this in a minute. But before you do that, I'm going to show you something else that's quite important. And which often goes hand in hand with these things, and that is exception handling. So sometimes things in our program don't work the way you expected them to. So for example, if we look at our previous code, we ask the user to input two numbers. Now, the user might not input two integers. They might put in the word Dan, for example, in which case our program is going to fall over because it'll try and cast the word Dan to an integer, and it won't be able to do that. So what would happen is the program would terminate with an error. And you'll have likely seen that many times already when you're doing the exercises that an error pops up. Something's gone wrong. Now, that's fine, but it's also messy. And it's a far better idea to try and capture the error, catch it when it happens, and then deal with it within the program, rather than getting the program to stop and then sort of collapse out. It's not very nice for the user if the program just terminates and gives an error message that they probably won't understand. Far better to deal with the error in some way. And one way to do that is to use in Python a try and except statement. So basically, a try and except statement is just a way to tell Python to try doing a block of code, but that if anything goes wrong within that block of code in the try statement, to then run the block of code in the except statement. Okay, so here's an example. So we've got our function as we had it before, multiply and check. But here I've amended things so that around the user input, I've said try doing this user input, try doing that bit of code. Now, if the user inputs a number as we want them to, then that's fine. We'll just carry on and we'll go to the next bit. But if they input something that causes an error, so let's say they input the word Dan, then that's going to chuck up an error. So rather than crashing the program out and throwing up a Python error message, instead what will happen here is it'll then go to the except bit. So then say, okay, if that goes wrong, do this. And here, I've just got it to say, sorry, you didn't input an integer. We'll use a random number instead. And I get it to randomly generate a number between 1 and 1,000, and then tell the user that's the number you're now using. And you can see that's a much more elegant way of handling things. So if the user does something that you don't expect them to, and let's face it, they're users, then you can catch that and deal with it in a better way, rather than just getting the program to collapse. And that's really important, particularly where you've got an external factor coming in. So where you've got the user inputting something, or where you're trying to read in a file, as we'll see later this morning. So it's a really good practice to get into using try and except statements. And the other thing to flag up is that, so we've only got one line of code in this try statement, but you could have multiple lines of code. And the try statement will fail if any of those bits of code fail. So if any of those generate an error, then it'll move on to the except statement. Now, as well as try and except, we can add to a try and except statement by using the keywords else and finally. Now, I don't tend to use these so much, but it's worth knowing that they're there. So remember, try says, try this code, do that first. If that goes wrong, then run everything that I tell you to in except. Essentially run this as if an exception occurs. We can also use else to say, run this bit if you didn't get any exceptions. So if you didn't get any errors, it'll run the bit in try, and then it'll run the bit in else. And we can also use the word keyword finally, which basically says, regardless of whether the bit in try worked or not, run that. So try this, do this if an error occurs when you try that, do this if you didn't get any errors when you did the try bit, and then finally do this regardless. You probably won't use else and finally quite so much, but they are ways in which you can make the try and except statements even more elegant and comprehensive, particularly if you're doing more advanced error handling. Okay, so enough of me talking. Let's get you to practice using these skills of defining and using functions and using exception handling. So what I want you to do is to spend the next 40 minutes working your way through Python Prog Workbook 5. You're very welcome to do that either individually or in groups. If you're more comfortable and struggling a bit, then I'd encourage you to work in groups to do this. Spend the next 40 minutes doing that, so we'll come back at 25 past 11. I will this time remember to post up the question, but let's just have a look at the questions I'm asking you to do. So task 1, I want you to write a function that takes as its inputs 2 lists of any size and then compares them to see how many common elements they have, i.e. how many things are in one list that are also in the other, and then returns this number. So here you've got a function where you've got 2 inputs and they're both lists. The function will then check to see how many elements in one list are also in the other list, and then it'll return that number, the number of elements that are in common. And then I want you to try that function out by calling it with 2 lists. Those lists can be anything you like, but try different combinations of common elements. So set up some lists with no common elements, set up some lists with 2 or 3 elements in common. And after the function's called, print a message that confirms how many elements are common to both lists. And I want you also to add exception handling such that if anything other than 2 lists are passed to the function when it's called, a message will appear saying that something went wrong, and the message about the number of common elements is never displayed. And you can test that by passing something other than 2 lists, for example, 1 list, an integer, whatever it may be. Try out your error handling. And then in part 2, I want you to write a function that asks the user to input 5 integers and adds them to a list, which is then returned. Then call the function you wrote in task 1, using the returned list as a replacement for one of the lists used above to see how many elements from the user list are also in the other list. So rather than using the 2 lists you hard code here, you're going to essentially use the user input list as one of those lists. And again, you should put exception handling in this code, particularly around the user input. So if the user inputs anything other than an integer, a message will be displayed telling them it must be an integer, and they're asked to input that again. And the code should only proceed to ask for the next input once the user has input an integer. So it'll keep asking them for an integer until they put in a valid integer. So if they get to the first number and they put in the word Dan, then it'll say, no, you need an integer, give me the first number again. And it won't take the first number until they've given them a number. Okay. Actually, I'm going to strongly encourage you to work in groups for this. I think there's quite a bit here to get through. So I would advise you work in your groups to do this. And as I say, we will resume at 25 past. You may want to take a short comfort break somewhere in there as well. Stretch your legs and make a cup of tea or whatever. And we will come back at 25 past. Any questions about any of that? No? Great. If you get stuck, as I say, shout. The mentors will be floating around as well. But otherwise, good luck, work in your groups, and have a go at writing some functions. Brilliant. See you shortly.